Now let's look at the fourth example for this topic, stones on the table. So the problem essentially says, given a string of length n consisting of characters RGB, and we are supposed to compute the minimum number of characters that need to be removed so that in the remaining string, no neighboring character are the same. So given this input, length 5 string RRRRR, we have to remove 4 of them in order to have no neighboring character are the same. Because we have R appear five times. So if we have 2 of them left, it will be RR. Then it's 2 neighboring character are the same. So we have to remove 4 of them. And here we have to remove we have a BBB, these 3B, we have to remove 2 of them. And then G is fine. And then we have a BB, we have to remove 1 of them. And then we have RR, we have to remove 1 of them. So we have to remove 2 plus 1 plus 1, 4 of them. So that's the problem. So to solve this problem, one approach is we go through the strings from beginning to end and look at each character. And in order to determine whether we can keep that character, we need to remember what is the most recent character we have kept. So what is the previous one? If the current character is the same as the previous one, then we have to throw the current character away. So then that means we need to remove 1 more. So there's just no way around that. Otherwise, then we just keep current character. Now we need to remember this current character is the one we should remember because this is the one we are going to compare with the next one. So here's one version of code to deal with that. So reading n, reading the string s. Then we use answer variable to store the value we're going to compute. So we initialize to 0, and in the end, we're going to compute it. Then we're going to loop over all the characters, and then we need to remember what is the most recent character. So here in the code, I just remember the first one as the most recent. Then I'm starting from index 1, starting from the second element. So the logic in the loop is very simple. We're just saying if the current one is the same as the recent, then we have to throw the current one away. We have to throw SI away. So then we add 1 to the answer. And in any case, we need to update the recent to be the current one. I guess maybe a little bit more intuitive logic is to have a else here. But it's logically equivalent. So because in some sense, the if branch means that we are throwing things away. So we don't need to update what is the reason. But having that is also correct because in this case, SI is the same as reason. There's no point in when we update the reason equals SI, it will be the same. So whether we have else or not, the code is equivalent. But I guess conceptually, this is more logical. We are saying there are 2 cases. The current character SI is the same as the previous one, in which case we throw the current one away. Otherwise, we keep it. Then we have to update a recent to be the current character. Because next time when we look at the next one, this SI should be, because it was kept, it is the most recently kept character. And then we just print the answer in the end. And an alternative version is instead of using the first value as a reason and starting by looking at the second value, if we want to start looking at the first value, start looking at the index 0. I guess actually, if in this case, we don't need to explicitly use the index. We can directly say for C in S. So, and in that case, I need to make this recent recent value to be something that can never appear. It can never be a character. So actually, let's write out this version. I don't think this -1 thing is actually correct. I guess I can make it empty string. So let's actually type this code on online GDB. Here, okay. Okay. So we're going to make this empty string because in Python a character is simply a string. So we don't need the comment. Then instead of doing this, I can just do ch in s. So ch for character. So then if ch is the same as this, otherwise resident is ch. So let's get some test case. Because I can use this one. Okay, so it's 4. So I'm not going to submit it. I think this is correct. So we use this to remember the most recent character, but initially we assign it to a value that can never appear. So in this case, we use empty string because the character is length 1 string. So that's one way to do it. Another way is to observe that basically what happens is for every 2 consecutive characters that are the same, we have to remove one of them. So another way to look at it, just every character, we look at it to see whether it's the same as the previous one. If it is the same, then we have to remove that one. So the same logic can be used without actually removing any. So this is the version implementing that. So we are looping over starting from the second character. And if we find out that is the same as the previous one, then we just add 1 to the answer. So this may or may not be immediately obvious to you that is correct, but if you are puzzled, I guess take a string and apply this, run this code and get the answer, and then use some other way to figure out your answer and see that they are going to be the same.